All right, let's get started. I'm just waiting for a couple more minutes and we can get started pretty soon. All right, so this is going out to both YouTube Live as well as on Zoom. So you can catch it on either of these channels. And we're going to get started. I think it's the right time. Let's get started. All right, so hi everyone. Welcome to this live code session. It's been a while since I did one of these. And I think I want to start doing more of these as we go along, especially because there's a lot of stuff out there that we've been doing at V45. And I think there is a lot of live code that we've brought out. We've done a lot of things, especially on the tech stack side. We've built some new products. And as a result of that, we have kind of gone a little further in our understanding of cloud security, Kubernetes, etc. Kubernetes security, mostly on the specific security side of all of these things, right? So yeah, since we last did this session, we've had a bunch of trainings. We did the training at Black Hat. It was a lot of fun. We did a bunch of OWASP talks. I think we're doing some more over the course of this month and the next. And we're also in Black Hat EU in December. So definitely check us out. If you want to learn stuff about DevSecOps, then definitely check us out on Black Hat EU. So let's get started with this one. I'm going to start sharing my screen in a little bit. Let me just move this to the right screen and I can start sharing my screen. Just give me a second here. One second. I think I need to desktop 3. Here we go. Right. So so this is the session today is about mutual TLS on AWS API Gateway. I don't know how many of you saw the announcement in September. This was a announcement by AWS. I think the serverless team made this announcement that they support mutual TLS, which I didn't know about actually, even though I follow the serverless team in AWS quite a bit because we write a bunch of serverless apps ourselves. I had missed this announcement at some point. You can't hear me. Just give me a second. Maybe there's something wrong with my mic. One second. Let me just see if I can. Can you hear me now? Okay. Looks like people can hear me now. I'm not sure whether that was one person. Yeah, loud and clear. Okay, cool. I guess that was just one person. Then sorry about that. All right. So yeah, so I usually we're usually up on a lot of the announcements from the AWS team, but for some reason I think we'd missed this announcement, and this was a pretty important announcement as far as we were concerned as well, because mutual TLS is a pretty useful security feature. Especially if you're dealing with anything related to cloud native stuff or Kubernetes or microservices or even IoT services being deployed at scale, mutual TLS is a useful security feature to have. So this is why I was, I missed this and I was not feeling very happy that I missed this announcement. And if you've noticed, mutual TLS has kind of become a mainstay thing, right? You've seen this. In fact, Cloudflare announced mutual TLS capability just last week. In fact, Cloudflare has been doing a bunch of announcements for something they call Zero Trust Week. And as a part of Zero Trust Week, they've announced a set of products for mutual TLS. So that's why it's important when we talk about why it's important. And we're also going to do a bit of a live demo as to how to set it up and how it works and why it works the way it works. All right, so let's get started, and I'm just gonna have to change my screen here. Yeah, so yeah, this is me, Abhay. I'm sure some of you in this stream know me. I see some familiar faces in the audience list in the stream as well. So I'm happy to see all of you. Of course, this is I do this a lot. I do a lot of training. I do a lot of development at V45. I handle technology at V45, and this is what I do. I also do a lot of training at Black Hat, DEF CON, and so on. So just a quick introduction of me before we get started. Just give me 1 second. My screen is being. So if you want to follow us, of course, we have a very active channel and blog. We keep putting out new stuff, and you should expect a lot of stuff coming out of us. Our research over the next 3 months, we've been doing some very interesting things, and you'll see a lot of it on YouTube. You can follow me on Twitter at Abhay Bhargav and V45 at V45 as well. So you can check us out and see our talks at these events. We do a lot of our folks speak at multiple events. You can definitely check us out at one or more of these events. Today, I do have some live demos, and live demos are always a little scary. So please do pray to the demo gods for me. I do have some live demos, and I'm setting up DNS from scratch. So DNS is always a little bit of a pain. I'm hoping I have a pre-set up environment already. So if things kind of flake out, then I will use that pre-set up environment and I'll explain how I did it. But in the event that it actually works, then hey, you know what? Prayers are not gone for naught. So why mutual TLS? I'm going to kind of cut to the chase here. I'm not going to get to too much preamble about this because I want to keep this short. So first of all, mutual TLS. So first of all, what is mutual TLS? And why is it that important? So mutual TLS, so typically when you have TLS, you have a client verifying a server certificate, right? So that's how TLS works. So you have a certificate that's deployed on a server, and a client essentially asks for that certificate, verifies the certificate against a list of pre-existing certificates that it has, make sure that the certificate chain is valid, and then starts to communicate in a secure way with the server, right? So essentially the server's identity or the server's authenticity is being verified, but the client is not necessarily being verified. The client is not verified. The client is verified maybe in your application. Your application may have an authentication piece. It may have an authentication authorization module. That's something, but that's nothing to do with the client being verified for in any way by the infrastructure itself, right? So the client is not really verified. So this is kind of, when you're dealing with a human interaction, especially when you're a human sitting on a browser accessing something, or a human being accessing something on even a client application, then HTTPS kind of makes sense. But when you're dealing with machine-to-machine communications or microservices talking to other microservices, especially, let's say you have a massive deployment of microservices where each of these services have to discover and talk to other microservices, then obviously it's going to become a little harder, because remember, there may not even be a context in which this service knows that this service exists. It might be a new service that's cropped up in the environment somewhere, or in an IoT network scenario, there may be a new sensor up somewhere that is trying to talk to the network and start accessing the network for certain things. So when you need to have machine-to-machine workflows, trust is harder to establish because there's no human being behind it. You don't have a human being entering their password, and you don't want to be able to inject passwords into each and every IoT sensor. It's a little bit more complicated, right? There's definitely a lot more complication with trying to inject passwords and trying to have this secure exchange mechanism. It's not exactly the most easy thing to do. I'm sure you'll agree. So you need something a little bit better. So one of the principles, or at least the core facets of zero trust, and zero trust is of course a much larger topic. I'm not going to get into zero trust today, but a lot of zero trust stuff that we see on the internet at large is about mutual trust and authentication. It not only means that there is this one Apex server component. It also means that, hey, you know what? I'm an application, you're an application. I should be able to trust you. You should be able to trust me. It is mutual, right? The trust has to be mutual, because what happens is that, like I said, there's a lot of service discovery. There's a lot of new microservices that are coming up, and they need to kind of discover and talk to each other. And if they can't, it becomes a little bit of a challenge. So that is where zero trust kind of hinges a lot on things like mutual trust and mutual authentication. There's of course a lot more to zero trust, right? There is a lot more. I'm not even claiming to go into the depths of zero trust, but definitely this is one of the building blocks of your zero trust framework. And if you have dealt with Kubernetes, right? So Kubernetes kind of gave me a first view of this. When I started working with Kubernetes about 3 years ago, this is when I actually started seeing the concept of mutual trust, because every component in Kubernetes authenticates itself to the API server or every other component through certificates, right? So typically what happens is Kubernetes, when you have a Kubernetes deployment, you typically have something called a cluster certificate authority. So it's like this private certificate authority that essentially issues certs, signs and issues certs to other components in the cluster, including users. So as a Kubernetes user, what you typically have is you need to generate a certificate signing request, send it across to the Kubernetes cluster. The cluster is going to somebody of, let's say it's an administrative user, the administrative user will verify your identity and then sign your certificate and send you back a certificate that you can use to start talking to the cluster from that point on, right? So one of the things you should realize with Kubernetes is that it's all about mutual authentication, right? Each component is talking and authenticating mutually, both ways, with each other and with the other component. So when the client is talking to the API server, it's a mutual transaction. Scheduler is talking to the API server, it's a mutual transaction. API server and kubelet are talking, it's a mutual transaction. So there are the entire Kubernetes distributed system is mutual authentication, especially based on certificates. So I kind of got this big orientation to mutual TLS, so to speak, when I started working with Kubernetes, and it's kind of became a very common thing. In fact, I realized that it's not as common in a lot of other components that we see, especially out there in the cloud, and even within organizations. A lot of cases you don't see it very common, but with Kubernetes and distributed systems, I realized why it became that essential. So when a user wants to authenticate, typically what the user has to do is generate a CSR, and the cluster or the cluster admin approves the CSR, and only then the user can start mutually communicating with the cluster CA. Remember, the cluster has its own certificate authority. So imagine, some certificate authority like your Symantec or whatever it is, that has it's a private Symantec that's essentially signing all the other certs and mutually authenticating. So not only is a client verifying a server cert, here the server is also verifying the client cert, right? So if you look at a mutual TLS workflow, you're essentially having a two-way verification going on, right? So you have the client hello, and then you have the server hello, and then a cert request. And then the client sends across its certificate, and then there is a system of encryption where the client essentially encrypts its data with the server's public key and sends it across. The server obviously can only decrypt it with the private key and then verifies the client cert with the client public key. So the server is obviously, since it has already signed the client certificate, the server already is able to verify that. So it's able to verify the public key because it is the one that has actually signed that particular public key or that particular certificate. So it's a mutual transaction. It's not a single type of verification that happens. I do have some questions. What exactly is the client in the K8s context? A node, a pod? A client is typically any K8s component, right? So the question from Garth was, what exactly is the client in a Kubernetes component? A node, a pod, anything, right? Any resource that's talking to any other resource is a client, right? And not really a client, but it's essentially a component or a Kubernetes. So Kubernetes has a bunch of control plane components. It has a bunch of node components, all of them that have to talk to each other. They have to have mutual authentication. So that's basically what, it's not really a client, it's more component to component. That's why it's machine to machine. That's why I spoke about that, or service to service. So mutual TLS works like this, right? So basically it's a two-way verification that happens, and only after that two-way verification is completely set up, only then the transaction, they can start communicating in an authenticated way. This is very useful because imagine that, let's say I found this, like I said, very useful with Kubernetes, and I'm going to go back to Kubernetes now and then because it kind of gave me an initial insight into this concept of mutual TLS. In Kubernetes, the thing is, imagine that you have, let's say, 10,000 nodes, and you have your control plane could be deployed anywhere. It could be deployed across. You could have your services distributed across 5,000 or 10,000 nodes. Obviously, they have to be able to communicate with some kind of understanding that it's mutual, it's not just one way, because something could just easily replay the API server and say, hey, I'm the API server, start talking to me. And it could have a massive breach in the cluster. And it happens as well. In fact, a lot of Kubernetes attacks based on certain misconfigurations can be leveraged to do things like that. But I kind of digress. Right, so AWS, one thing they did was on, I think, 17th September, they made this announcement that their API Gateway now supports mutual TLS, which is really good because the API Gateway did support JWT, it supported, authorizers from OAuth-based or OIDC-based workflows, but did not support mutual TLS. And mutual TLS is useful because remember, an API Gateway is a gateway to talk to microservices. Especially I use them pretty much on a daily basis for Lambda. So if I write serverless apps, I need my API Gateway to actually call my Lambda functions and then start to respond to these Lambda functions or have responses routed back to the particular user. So the API Gateway is a pretty critical service in AWS. You can use that to route the Lambdas, you can use that to route the servers, you can use that to be a gateway for any other type of services that you want to serve up on HTTP, either a REST, or you can even use WebSockets. So API Gateway is quite a versatile gateway service. So the idea here is that today we're going to see a live demo of this. I'm going to set up an API Gateway with something called a custom domain. So API Gateway typically has a xxx.execute-api.amazonaws.com kind of thing. So that doesn't work with mutual TLS. You have to set up a custom domain for your API Gateway, and then you need to map it to another API Gateway service that can allow you to actually talk to your actual services, which could be an EC2 web service, it could be Lambdas, it could be some other compute service that's running a bunch of stuff. So basically, let's say I'm going to use Lambdas today because they're just easy to spin up, but this could be any other REST or HTTP service that you want to route to, right? So basically, that's what we're going to be doing. And I'm going to be doing a live demo of this as we go along. So let me just pull up my AWS console. And actually, like I said, I already have a pre-set up environment. In case this crashes and burns, then we're going to go with that environment. All right. So the first thing we're going to do is we're going to set up a certificate, a TLS certificate. I'm going to use AWS ACM. You don't have to use AWS ACM, which is the certificate manager that Amazon comes with. So I've already set it up. This is my pre-set up environment, as you can see, API. I'm just going to kind of zoom in my screen a little bit. So I'm going to create another subdomain, and I'm going to call it mTLS.AppSecEngineer.cloud. Okay, so this is just a subdomain. So imagine that this is the gateway URL that I need to use to route my microservices, right? So that's basically what this is. So I'm going to use this, and I'm going to say, okay, I'm going to validate this with DNS, and that's really it. The certificate is issued. So one of the things with being in the walled garden of AWS is that pretty much everything becomes very easy to get done, right? So in fact, since I'm hosting my DNS records in AWS, I can just say create record, and it just creates that record, right? So I'm going to create that record, and I'm going to continue. So now the certificate for this particular URL, for this particular subdomain mTLS.AppSecEngineer.cloud is issued, right? So I need a custom domain. I can't use AWS's default API gateways. That's not allowed. So AWS still doesn't support that. And yeah, so this is done. It's already issued. The certificate is done. The DNS entries are done. All that is done. So let's move on to the other service that I need to set up, which is my actual API gateway. So before I set up my API Gateway, let's actually create a small microservice and deploy it on AWS Lambda. So I'm going to create another directory here called SLS2, and I'm going to create another directory here called mTLS SLS. or mTLS. I'm just going to call it SLS. That's fine. Now here I'm going to create two files. I'm just going to create one init because Python needs to find the module. It's going to create this, just nothing. There's nothing. There's no real value to this. And then I'm also going to create another file called handler. This is my microservice, right? So this is my actual microservice that I am creating. So my microservice is going to be, I'm just going to do a very basic so I'm just going to call a function my microservice context. So this is a Python microservice that I'm just coming up with. Oh. Right, so I'm just going to leave it there and I'm going to implement this. Now this is going to respond. It's just going to do a basic response. It's not going to do anything. It's just going to respond with a status code of 200, which is an HTTP status code. It's going to have a headers dictionary with a content type, and the content type set to this. All right. And so it's a JSON. So we want to return JSON. So we're just setting the content type. And we're going to set a body to just give me a JSON value of sheesh. So this is going to be hello mTLS live code. So just some JSON response, right? So with this JSON response. Right. So now this is done. So my first microservice is run. I mean, it's written. So I'm going to have to deploy this. So for me to deploy this, I need to create a deployment spec. And I'm going to call that serverless.yaml. And because I'm going to be a little lazy, I'm just going to copy my existing one here. And I'm just going to make a few changes to this. So I'm going to say mTLS2. This is a new stack, whatever. I'm going to deploy it to US East 1 because US East 1 is where they have the support for the mutual TLS thing, right? So I don't think the API gateways in other regions have it yet. I'm not 100% sure, but this is, I think what I read was that it works only on US East 1 right now. I'm not 100% sure. Maybe I read wrong, but let me just copy this function over. And yeah, so this is, I'm going to say hello. So essentially, we're going to create a microservice with this particular part that says, hey, say hello. And then it's going to, if you make a get request to that, it's going to come back with this JSON response, which is hello mTLS live code. That's it. Okay. So what I am going to do now is I'm going to deploy this. So I'm done with this. I'm actually done, ready to go. I'm going to, so my file is ready. My deployment file is ready. I'm going to deploy this to my AWS. So it's going to create an API gateway for me, and it's going to create a URL, and it's going to create the bindings to Lambda. So it means that, hey, this, as soon as you call / say hello on the API gateway URL, it's going to pass over. It's going to invoke the event on Lambda and then come back with whatever response comes back from Lambda. Make sure my code is actually okay. I think it's fine. Yeah, seems okay to me. Okay, cool. Yeah, serverless.yaml, it kind of transpiles it into CloudFormation under the hood. So it actually deploys CloudFormation. So Garth's question is serverless.yaml a CloudFormation deployment spec? Under the hood, yes, it does CloudFormation. But it just makes it easy for you to write out the YAML because CloudFormation is a little bit more verbose. This is a little bit easier to deploy. And it's cross-cloud as well. So you can use serverless.yaml for AWS, you can use it for Azure, you can use it for Google, you can use it for IBM, you can use it for OpenFast. Yeah, so it's, I kind of like using it because of that. You're welcome. Just waiting for this to deploy. Just give me, so it's 438 bytes, but you know what? It still updates the stack. It creates the API gateway resources. So it kind of just does the whole thing, right? So it kind of gives you a packaging of the entire thing, and it deploys the entire stack to AWS, right? So it creates an API gateway resource, it creates all the IAM privileges required for it. It does all that stuff. It also gives you it creates a routing for the API gateway. All of that is done, right? So that should be done pretty soon. And once it's done, you will see that this is accessible directly, right? So this is accessible immediately and directly but we don't want it. We want to have some mutual authentication, right? So that's what we want to do. So you see that it's actually created this API gateway URL with a GET request. So let's actually make a GET request to this. You will see that it comes back with, hey, hello, mTLS live code. Pretty straightforward. That's what we wanted. But this is not the fun part, right? We've just implemented a basic serverless function that comes back with some response. It's a basic web service of sorts that we've created. Now is what we need to do with AWS. And this, unfortunately, I don't think AWS has still created an automated workflow for this because it's still a new feature. So I'm gonna have to do this manually on the console. I would prefer to do this on Terraform or something like that, but I don't think there are. I checked, but there's no serverless bindings for this. I don't think Terraform supports it either, although I'm not 100% sure. But I'm going to do this on the console. Okay, so now I'm going to go into the API gateway, and you can see that I have a crap ton of API gateway entries here. So this is my API gateway, right? So this is the one I just deployed. So you see that it has this whatever URL, and it has the routes, and you see there's only one route, which is the say hello route, and it calls the Lambda function. So that's the Lambda function that it calls, right? So it calls the Lambda function called say hello, right? So basically that's what's happening here. So this is the stack. So we want to be able to connect our custom domain, which we just created. Remember, we created this custom domain called mTLS, and we want to be able to do mutual TLS authentication between the client and the server. So remember, the server has to authenticate to the client, and the client has to authenticate to the server. So both things have to happen here for this to work, right? So what we're going to do now is we're going to set up our custom domain names, and I'm going to create another custom domain. We're going to call this mTLS.AppSecEngineer.cloud. And I'm going to give it a TLS 1.2, and I'm going to enable mutual TLS authentication, right? Now, as soon as I enable mutual TLS, it says, hey, how do you want to handle the root CI? So essentially, when you're saying mutual TLS, you're essentially signaling to the API gateway that, hey, you need to kind of give me some kind of a certificate authority capability for me to be able to actually sign and validate certificates on your behalf, both for the client signatures as well as to validate client signatures, right? So as soon as you enable this capability, what you're doing is essentially signaling that you need to upload some kind of, in this case, it's a S3 bucket thing that we're doing, but you can do this with, so you can actually use AWS Certificate Manager and create your own private CA and all that. I'm not going to do that. It's a little bit more complicated, but I'm just going to create another, I've actually created a root CA. I'm just going to use that, and I'm going to give it a particular location. So I've already created a bucket, and I'm just going to paste that bucket's ID here. Just give me a second. That's going to be here somewhere. AWS. Yeah, I've already created this trust store. So this is the root CA file, root CA public key that I've already created in S3. It's essentially going to be in here, and I'm just going to use this, right? So this is the, I'm just going to use this location as the trust store, which is as a PEM file format, which is your certificate, right? So I'm just going to apply that, and I'm also going to associate that with a certificate that I created for my mTLS. You remember I created this TLS certificate for my mTLS. I'm going to associate that with the mTLS, the certificate that I just created, right? So I just created the certificate, and I'm going to create this domain. So this is a custom domain. So now instead of making my HTTP request to this, long weird looking URL, Amazon AWS.com, I can make my request directly to mtls.appsecengineer.cloud/say hello, right? That's one good thing. The other thing is that since we have a mutual TLS setup, the domain, it has the CA capabilities to actually handle mutual TLS at the gateway itself. Okay, so now that this is configured, we have to map this to our API gateway. We already created an API gateway object. We need to map it to that object. So let's map it to that object. We're going to say API gateway. So let's so we're going to use we just deployed this. So we have created this custom domain. We need to map it to a API gateway object, right? Because it has to actually route to that API gateway correctly. So we're going to map it here, and we're going to say default state. I'm not going to give any specific path. You can say V1. You can actually create multiple mappings. You can say V1 goes to this, V2 goes to this, V3 goes to this. You can actually create all of those different mappings as you please. I'm not going to do that because it's a very simple, just a basic API. I'm just going to map that out. And the next thing I'm going to do is I'm also going to make sure that the DNS entry is set up here. So I'm going to map this back to DNS. Remember, we need mtls.appsecengineer.com to start cloud to start talking to this API gateway when DNS resolution has to happen. So we need to set up the DNS resolution here. So I'm just going to create this, and we are going to go back here, and we're going to add add an A entry here. So I'm just going to use simple routing. I'm going to say simple record. I'm going to say mtls.appsecengineer.cloud. I'm going to route it to the API gateway. I'm going to say, hey, this is on US East 1 for me, and I'm going to use this. So let me just make sure it's the right A18, whatever. Yeah, seems to be fine. So it's routing to that. It's going to define this record, and I create this record. Now, this sometimes takes time. So when I did this in the morning, it took like almost 15-20 minutes before it actually came up. But if it does happen this time around, then I'm going to show you in the pre-setup environment that I have. But if it works, then it works. Right. Now, the next thing we're going to do is also turn off the previous gateway that it had, right? So you remember that we had already created an API gateway for this. We're going to, so we don't want people to directly access this URL, right? So if we access this URL, even now, I can get access to my API. I don't want that to happen, right? I want to turn off the ability for somebody to access this URL and talk to the API. I only want them to go through my mutual TLS route, right? So it has to be mutually set up. So I only want that to happen. So what I'm going to do here is go back to my APIs, go to mTLS, and here I am going to the edit, and I'm going to say, you know what, don't make this the default endpoint. This is not the default endpoint. The endpoint is going to be mtls.appsecengineer.cloud. So only that is the routing you need to support. So I'm going to turn off this default endpoint. So essentially hardening it a little bit so that you don't do all this nice security stuff and then open it up in the back door for somebody to access, right? So you don't want that to happen. So now that we've disabled it and it's set to auto deploy. I don't think I need to deploy it again. Yeah, I don't need to deploy it. Yeah, it's already set to auto deploy. So now if I try and access, so let's see. Let's try and access. I need to go back to my. So now let's create a new user, right? So let's say I am a new user called Abhay. So I want to create a new user and I want to generate some certificates for that user to come in. So I'm going to create a new user and I'm going to actually sign that user with my root CA. So my root CA key is already here. I'm going to use my root CA key to sign that user certificate signing request. And then that user is going to start. The idea is that user should be able to start accessing the API gateway, right? So I'm going to generate a cert here. I'm going to call this Abhay.key. So it's going to generate an RSA public-private key pair. And I'm going to generate a certificate signing request with that public-private key pair, right? So with the private key, I'm going to generate a certificate signing request. right? So sorry about the horrible spelling there, but it's fine. So I've just created a certificate signing request. So if you look at my CSR, you'll see that there's a certificate request. Now remember, just because I have a certificate signing request, I don't have access. I need to have this signed by my root CA, right? So I need to have this signed by my root CA. So if you have like a private CA, so if you're using Amazon Certificate Manager or something, you can import this and have this signed and then generate a user certificate through the API and stuff like that. But in this case, I'm not going to go through all that trouble. I'm just going to sign it with my root CA that I already have here. And I am going to make some minor changes to that root CA cert file name. So now I have a signed certificate. So abhay.pem is a signed certificate. Okay. Now let's try and access our API. Okay. So let's see HTTP GET without any mutual TLS, remember. mTLS.AppSecEngineer.cloud. And it should fail, right? You see that it doesn't work because there is no mutual TLS happening. There is no mutual authentication happening. Though the client is not able to verify, the client may be able to verify the server, but the server certainly can't verify the client because there is no certificate that the client is providing. So let's try a slightly different route. So instead of doing this, I'm going to now change a few values here. Now I'm going to actually, so now I remember I am a, mTLS. Now I have a certificate and my key. So what I'm going to do is I'm going to use my certificate to try and access that endpoint. So you see that what I'm doing is I'm making an HTTP request, but in this case, what I'm doing is I'm validating it. I'm sending my cert and I'm using, so one of the things that I commonly get asked is, hey, are you actually sending your private key over the network? No, you're not. You're essentially encrypting the payload and then sending that payload. So this is not being sent over the wire so much as being used for encryption before some, the encrypted data set is actually sent over the wire. So this is not being used to, this is not sent over the wire, right? So I'm going to try and access it now. Hopefully this should work. Oh, does it say hello or hello? Looks like I don't. Yeah, this sometimes takes some time because of the DNS thing. Yeah, maybe I'll try the S3 thing again. Just give me a second. Sometimes with the S3 thing, it works a little better if I try and do it again. I'm going to copy the trust store again, and then we'll try it again. But in any case, I have a previously set up environment, so just give me a second. Oh. Yeah. No, I don't think this is working for some reason. So there's a key value mismatch. Let me just access my the other one, the older setup that I had. So HTTP. Yeah, so this is actually a setup. Same again, I'm accessing as a client, I'm accessing a pre-built setup. So the DNS thing takes a little bit of time to propagate. So as a result, sometimes this takes a little bit of, takes about 30 minutes sometimes. So you see that when I do this, I'm able to access my API, right? But when I do it with, so this is, remember, I'm mutually authenticated. So both ways are being authenticated. And as a result, you're able to see that I'm able to access the microservice. right? However, if I try and access the same microservice without this, without actually, sending my client certificate across, you will see that it should work. Yeah, I think it aborted. I'm just, I think I might have put in an extra space in there. Yeah, so you see that it doesn't work, right? So it fails because it's not able to verify the mutual TLS. But if I actually use my Client-Cert correctly, you will see that it works just fine. Right, so that's one of the cool things about mutual TLS, right? You can just issue certificates, and you can, and this is a little bit more robust than using passwords, right? Because in passwords, especially if you have users pick their own passwords, then that's a whole other can of worms. But even otherwise, this is a little bit more scalable because injecting certs or generating certs from a root CA is a little bit more trust oriented rather than having passwords being injected into different devices and different services as environment variables. Yes, of course, there is a little bit of a convenience trade-off, but for machine-to-machine or service-to-service communication, especially when you're dealing with a lot of distributed services, this is definitely a good way to go because you're having both sides of the equation, both the calling app and the serving app or the client and server, whatever you want to call it. They are mutually authenticating with each other, right? So that makes a big difference in this particular case. So that is one of the benefits that we have with mutual TLS. Now, mutual TLS is supported by not only AWS, but a lot of different API gateways. So if you use Kong or if you use Cloudflare, if you use Istio, so if on Kubernetes, if you're on Istio, you're using Istio, you can use Istio. One of the features that they advertise as a big big security win as far as they're concerned is the ability to do mutual TLS, right? Let me just pull up that policies. I think it's in policies, or I'm not sure in which part they have mutual TLS, but yeah, they do have the ability to do mutual TLS. So Istio has that capability as well. Yeah. Right, so I have another question from Garth. Is there a built-in support for certificate pinning in AWS? I'm not sure. I have not explored the AWS Certificate Manager so much. I have to get back to you, but I'm not sure. Yeah, so yeah, this is our session on mutual TLS. Pinning is much more on the client side. Yeah, but server side would have to do that, right? It would still have to verify. Yeah, I suppose you're right. But in this case, it would have to be a certificate issued by the same root CA. So I'm guessing that, I'm not sure if that counts as certificate pinning. So it would be pretty much the same signature, right? When it looks at certificate pinning. So yeah. Yeah, so I would say that this is certificate pinning in that sense because you are essentially having only certificates issued, by that root CA to be verified. So both the client and the server would essentially have that transaction completed based on certificates issued by that root CA. So it is pinned, is what I would believe, unless there is a slightly broader definition of pinning that I'm missing something of, and I may be. Right. So yeah, so this is our mutual TLS session. So I just thought I'll do this. This is a small feature that AWS has introduced as part of the API Gateway, but I thought it was useful, especially because I run a lot of payloads and workloads on API Gateway, and yeah, so that this was a very important feature as far as I was concerned. So I thought let's talk about it and share some of this that we've done. All right, thanks very much, and have a good rest of your day wherever you are. and have a good weekend, which is coming up shortly. Thanks so much, and bye-bye. Thank you for joining.